Look, we are completely bypassing the pleasantries today because this explainer tackles a problem that literally strikes fear into computer science students. If you're prepping for your Cambridge IGCSE exams, you already know the harsh truth. Just writing code that works, yeah, that isn't going to be enough to secure top marks. You really need to understand the environment that your code lives in, the exact terminology the examiners are hunting for, and of course, the hidden traps in basic programming constructs. So today, we're going to fix a major leak in your exam technique by looking at something you probably click past every single day.
Okay, picture this. Let's dive into this exact system warning you might see when you're trying to save your very first Visual Basic program in the default source repos. You know the drill. You fire up Visual Studio, you create firstprogram.sln, and boom, you get this little note about the default repository folder. It's usually tucked away in your C drive under Users, Source, and Repos. And what do most of us do? We just hit OK and completely ignore the whole shebang.
I mean, it seems totally harmless, right? But here is the kicker. Misunderstanding file locations and IDE structure is exactly where students bleed easy points on simple file management and system context questions. When a Cambridge exam asks you to explain where a local project file is stored or how you might transfer it using external storage devices, well, panicking or just throwing out a vague answer about saving it to the computer is going to score you absolutely zero.
And this is exactly why ordinary revision just fails. It completely ignores how Cambridge examiners actually award marks for understanding this broader system context. Just memorizing some textbook definition of an integrated development environment is not going to save you when the exam throws a specific applied scenario your way. You can't just know what a folder is, you have to know how to articulate its specific role within the entire development process. So to fix this, we're using the Mark Magnet framework. Think of this as your secret weapon, a top-band exam strategy to literally secure full marks. When you face a tough question, you don't just write a sentence. No, you build an answer. Step 1, identify the core concept. Step 2, pull the exact evidence or data from the scenario they gave you. Step 3, apply the scientific reasoning, like how does it actually work? And Step 4, lock it all in with precise examiner wording.
Moving right along to Section 1, IDEs and Interfaces.
Before we even write a single line of code, we really need to understand the interface we're building for. The jump from a simple text-based console interface to a much more complex Windows Forms application is massive. A console application pretty much just accepts and displays text, but a Windows Forms application, that relies on graphical user interface or GUI tools, which means you, the programmer, have to design complex, interactive visual elements. So the absolutely crucial point here is that in Visual Basic, things don't just magically happen. They are triggered by specific user events. This is the core definition of event-driven programming. When you place a button on that complex GUI we were just talking about, it basically just sits there waiting. It is a user-controlled event, like pressing the Enter key or clicking that exact button, that triggers the execution of code hiding inside a linked subroutine.
Now, in just a second, I'm going to show you the exact examiner clue that flips a weak answer completely on its head. But first, you really need a framework that makes that clue super obvious in the first place. Because, understanding what an event is, well, that's only half the battle. The other half is understanding the strict order in which these events and calculations are actually allowed to happen.
Which brings us to Section 2, Programming Constructs, specifically Sequence.
The most fundamental programming construct you're going to be tested on is sequence. It sounds incredibly simple, but trust me, it's where most of the logical errors happen. Think about your phone's sat-nav calculating an estimated time of arrival. Step 1 is obtaining the start point. Step 2 is obtaining the end point. Now, you could probably swap the order of 1 and 2, but Step 3, calculating the actual shortest route, absolutely cannot happen until the first two are locked in. Without that data, the execution just fails entirely.
And that brings us to the formal definition you actually need for your exam. Sequence is the order in which code is written, which is usually top to bottom. The program is going to execute the first line of code completely before it moves on to the second line, and so on. A classic sequence error would be trying to process a calculation, like that sat-nav route we just mentioned, before all the appropriate user inputs have even been obtained. Examiners are actively hunting for these logical sequence errors in your algorithmic designs.
All right, let's test those exam instincts for a second. Try to spot the error in this phrase. A button runs the code. Just pause and predict. If you wrote this in a Cambridge exam when they asked you how a message is delivered in a GUI, what mark do you think you'd get? Really think about the technical depth we've been talking about.
Well, if you guessed 0 marks, you hit the nail on the head.
That flawed answer is just way too generic. It sounds like something your grandma would say, not a computer scientist. Now, check out the top band upgrade. Selecting a button on a GUI is a user-controlled event triggering a specific subroutine. See the difference? This uses our mark magnet framework perfectly. It clearly identifies the mechanism, a user-controlled event, and it correctly names the programming structure that actually holds the code, which is the specific subroutine.
Okay, here is that massive examiner clue I promised you earlier. Generic answers are incredibly weak, so you must always lock your technical definitions directly to the specific scenario nouns and constraints they give you in the question. If the exam scenario is about a weather station collecting rainfall, please don't just say the user inputs data. Say the weather station operator inputs the monthly rainfall data in millimeters. Using the specific nouns from their scenario proves to the examiner that you aren't just regurgitating memorized facts, but that you're actually applying computational thinking to the problem at hand.
So, we've mastered the IDE concepts, we've nailed the sequence logic, and we've got the mark magnet phrasing down for our definitions. But what about the top band evaluation framework? Leaving now means you're going to completely miss the specific evaluation framework required for full marks on paper 2, which is where you actually have to evaluate algorithms and system designs. Knowing the terms is great, but it isn't enough when they ask you to evaluate efficiency or suggest concrete improvements.
To solve that unresolved problem and secure those absolute highest grade boundaries, you got to jump into our next explainer on evaluation frameworks. Oh, and don't forget to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to really excel in your Cambridge examinations. I want to leave you with this final thought, though. If you can easily spot the difference between a simple user action and a triggered subroutine now, what hidden logic errors are currently hiding right there in your own revision notes? Keep questioning everything, and I will see you in the next explainer.